Okay, awesome. All right. So here's our ML workshop for beginners. And we're going to start off with a demo just so that you guys know what we're building. Okay, so these ones are run. This is the code, BT dubs. So you're getting an inside scoop. We're doing a tweet classifier. Okay, first, can you guys like send in the chat a tweet that you think sounds like something Trump would say, and then a tweet that sounds like something Justin Trudeau would say? Like if you know French, then that's even better because apparently he tweets a lot in French. Okay, I don't see anything in the chat yet. Who's Trump? It could. Oh my God. Phase naive classifier is the best. Yeah. Okay. Is that actually French, Drea?
Yeah, that's actually French.
Okay, I wasn't sure because that's my roommate and she sucks at French, so.
Okay.
Corn sales are down, failure. Perfect. I've never seen a thin person drinking Diet Coke. Okay, this is very exciting. Okay, so, oh no, I messed up. I know how to copy paste. Corn sales are down. Corn sales are down, failure. Okay, so we're gonna guess that my classifier is gonna guess that Trump said this and Trudeau said this, but let's find out. Corn sales are down, Trump. And the French one, Justin Trudeau, let's go. Okay, what if we say corn sales are down, but like without failure? Because I feel like failure is something that he says a lot more. Oh my God, it still worked. Sales are down? What if we do Canada sales are down?
I think it's also the fact that it's kind of capitalized.
Oh, let me try that. Actually, the way that the classifier works is it makes everything lowercase, but that's a really good idea for a future thing because I feel like Trump definitely does capitalization a lot more than Trudeau does. So next time, or if someone wants to do an extra thing, we could try doing capitalization versus lowercase. Okay, so when you do Canada sales are down, it switches to Justin Trudeau. So I guess he uses the word Canada more than Trump. All right, very exciting. Now we're gonna get started. So this code is adapted from a data scientist at LG Electronics. Just thought I'd give him a shout out. He wrote a really great article. So we're starting off with some skeleton code that I'm gonna post in the chat. Okay, so click on the link that I just sent in the chat, and then wait, I'll just do it with you guys to show you. Then you're gonna make a copy of the skeleton code, and then you're gonna like code on here. And it's really nice because it's like online, so you don't have to have Python or anything installed. So you're gonna go file, and then save a copy in Drive. And then it's gonna have your copy and you should be able to like edit it and stuff. Has everyone made a copy? Okay, I'm getting some nods. So I'm gonna take that as a yes. Okay, someone said yes, awesome. And then also I'm gonna send you guys a solution code just in case you have to like go to the bathroom or like take a phone call or you get lost. Then you can just refer to the solution code so that in the end will still work. And then we'll be here at the end to like answer questions and stuff. So also you could keep the solution code open in a new tab. Oh yeah, and also Rachel just sent the attendance form in the chat, so make sure you fill that out. We have to for Purdue. Yeah, someone said I like in-person meetings. I also like in-person meetings, even though there was a snowstorm, I was still trying to keep it in person, but had to switch to Zoom, unfortunately.
For the attendance, the first time I did it, I thought it didn't work also, but all you have to do is click it and then just look at the bottom of your screen. If there's a blue banner that says your attendance is tracked, you're all good. So.
Okay, so now let's get started. It's so exciting. Okay, so first, I already gave you the importing library stuff because that stuff is easy. You just like Google the name of whatever function you want to use. It'll show you the library. But now we're going to go to the second cell. Basically, each of those like chunks of code on Google Colab, is it Colab? Colab. Each of those is called like a cell. So I've like numbered them. So if you go to the second cell, we're going to be importing the data set. So there's this really cool thing where you can import a data set from GitHub without having to download it. So if you see, I've commented in the second line of the second cell, a GitHub link. So go to that GitHub link. And then do you guys see the button that says raw? Click raw. So you click raw, it'll take you to like a CSV of the whole data set. If you keep scrolling, you'll be able to see like a ton of Donald Trump tweets, and then you'll be able to see a ton of Justin Trudeau tweets. And then we're going to convert the CSV to a thing called a pandas data frame. Pandas is like a Python library, which is really cool. You'll be able to like take the data frame and manipulate this table really easily. So I don't remember how much of the skeleton code. Okay, here. So give me a sec. Okay, so what you do is after URL, you say URL equals, and then in single quotes, you're just going to put that, you're going to copy that link to the raw data set and paste it in here. Does that make sense to you guys? Okay, take that as a yes. And then the second line, we're going to convert the CSV into a pandas data frame. Does anyone know how to do that? Like just type in the chat how to convert a CSV to a pandas data frame, if you do.
One thing, Nikita.
Yeah, what's up?
Archit missed the first part of it. Could you send the link to that Google
Oh yeah, of
collab
course.
again?
Yep.
Thank you.
Oh, shit. Everyone in meeting. Okay, so I just sent the link to the skeleton code, and then I'm also going to send a link to the solution code in case you get lost. Oh yeah, a lot of people know how to do this. We got df equals pandas.read CSV. That's exactly right. So you're going to use that function in the second line. You're going to say the tweet df. We're just specifying that's like a data frame of tweets equals pandas.read underscore CSV. And then in parentheses, you're going to say URL here. Yeah, someone said to repeat it. We're gonna say tweet underscore df. Also, if you ever get lost, you can just go to solution code and it's all there. So tweet df equals, it's PD. Oh my God. Dot read CSV. And then URL. This is going to be your second line. Super easy to convert a CSV to a data frame. And then the third line is we're going to print like the first 5 rows of the data frame that we just imported, just to like, you know, have a sanity check, just to make sure that it's working. Does anyone know how to print the first 5 rows of a data frame? Okay, so just like type it in the chat. Yeah, dot head. So you can say tweet underscore df dot head parentheses, and that'll automatically, and then what you do is you click this play button. Okay, run anyways. Oh, you might have to click the play button for the top one first, and then you click, once it's done, cannot save changes. That's great. Oh, I'm so silly. Why am I playing the skeleton code? Okay, so it should look like this, where you have the URL equals single quote the URL, and then you have pd dot read CSV, then dot head. So you click play here, then once that's done, you click play here to run this code. And if it works correctly, it should show you 5 tweets written by Trump, which is just like the beginning of the data set. Is everyone here? Can I just see some like no's and yeses in the chat? Okay, I got some yeses. Let's go. Okay. Next. So now we have our data. We have our tweets data. We have it in a table. It's super nice. Now we're going to talk about training and testing data. So for those of you that don't have experience in machine learning, I can like explain this. It's very simple. Basically, think of it as like we have a ton of tweets. Some of them are by Trump and some of them are by Trudeau. But the thing is, we need to also be able to test our algorithm. Like once we build our model to like predict stuff, predict whether this tweet was written by Trump or Trudeau, then we have to be able to test it somehow. And so what we do is we just split the data set that we have into like a training data and a testing data. So like our training data is basically like if a teacher has a ton of problems to test their students, they might give some of the easier ones, a few challenging ones as like homework. So that's the one where like the students are like studying the material, they're learning it, they're practicing it, they're really like memorizing it, understanding it, whatever. And then we have a training set, which is like the exam. So we're like testing the students. We don't know how well they studied it, if it's going to work or not. It might not have a very high scores on the test, or they might have really high scores on the test. So that's what's going on here. We're splitting the data into like 2/3 training and 1/3 testing. So at the end, we're going to be able to see like how well the model actually worked. And then we're splitting our data set further into X and Y. So X is like the independent variable. So if you see here in number 3, we're splitting the data set into 4 different sections, 4 different tables. And oops. Move this to the side. That's fine. This is fine here. Okay. So oh yeah, okay. So basically here, we're just trying to specify like our independent variable versus our dependent variable. So does anyone know what our independent variable is here? You can just type in the chat if you have any ideas. Okay, I don't see any messages. So the tweet, yeah, exactly. So the independent variable is like all the tweets that we have. And the dependent variable will then be whether it was written by Trump or Trudeau. So you guys in here are going to insert basically, so you have this here. You have tweet df, which has the whole table. And now you're going to split it up by the independent and the dependent variable. Does anyone have any ideas how to do that? If you see in the data set, oh, sorry, was someone talking? Go ahead. Oh, never mind. That must have been a mistake. Okay, let me go to the data set to show you guys. And it's loading kind of slowly. This is the wrong data set. All right, never mind. Okay, if you look at the raw data set, basically there's like a column that says status and says author at the top. So the status one is like the tweets and the author one is Trump or Trudeau. So now in the skeleton code, you're going to put here, oh yeah, link. Yeah, we're on step 3, sorry. So we're going to put here, so does anyone know how to like split a data frame into like by column? You can just send it in the chat. Like if we know the column names are author and status, Yeah, that's one way to do it. I was thinking to just like, it's really easy in my mind. Yeah, exactly. DF and then call name. So you say, this is the name of our data frame. So you're going to go like tweet underscore DF. And then in brackets, you put the column name. So for the independent variable we have here is called status. So you just put, I think it's single quotes. Let me check. Yeah, single quotes, you put status. And then here in the Y, you say tweet underscore DF, which is as the last two people said, like, or the last person is the one I'm going with. You say like author. And then we've split our data. Let's go. Okay, now we're moving on to number 4. And we're going to talk about word frequencies. Does anyone have any like conceptual questions of like what's going on so far? Or are we like pretty good? Okay, I'm going to assume that means we're pretty good. Okay, now we're going to talk about, so far this makes sense. Cool. Now we're going to talk about counting words. So what's random state? Okay, honestly, I don't remember, but I can look into it and get back to you later. Sorry about that. Okay, so we're going to talk about 2 different methods to count words. One is a very simple, like you count word frequencies in each tweet. And we're actually going to code both of these as well to show like which one is more effective. So with count, we're going to count the word frequencies in each tweet. Like for example, let's say a tweet was like green apple. So it'll just give the weight of 1 to green and 1 to apple. Or red apple, give the weight of 1 to red and 1 to apple. But there's this cool thing called TFIDF that takes into account how frequent a word is in like all of the tweets. So for example, in this one, we would want, oh, Torrin sent an explanation of random state. Awesome. So for in this one, like obviously the color of the apple is more important than the word apple itself. If we were trying to tell like how similar 2 tweets were, we would want the green or the red word to be weighted more than the apple word. Because what if like all of the tweets are just about apples? So you want to compare them based on like what color apple, you know? So term frequency inverse document frequency is this formula right here, where we take like how frequent the word is and multiply it by log of the total number of documents divided by the number of documents containing I. So here are like documents is like each tweet, and a term just means like a word in the tweet. So for example, if we do TFIDF for green apple, we're going to get term frequency of 1 because green is there once, and then log, and then n number of documents is 2. We have green apple and red apple, so that's 2 documents divided by DF, number of documents containing I. So there's only 1 document that contains the word green, but here we have plus the log. It's just like base 10 for this formula. I'm not sure though whether it affects things. I guess the base of the law, someone asked in the chat whether the base of the log affects things. I think the base of the log would make a difference, but I guess a higher base of log might affect this more, might make TFIDF like change more as respect to count. So here we have log 2/2 because apple is actually in the first document and the second document. So let's see, I think I had already done number 4 because it's not as exciting to code. Basically, this first part is doing the count part, and where we just like count the number of times each word is in each tweet. And the second part is doing TFIDF. So we're dividing it by the inverse document. Okay, I'm gonna answer that right now. All right, now we're moving on to number 5, which is the naive Bayes model. Okay, so naive Bayes is based off of this naive Bayes rule in statistics. I don't know if you guys have heard of it. This is the rule: probability of C given X equals probability of X given C times probability of C divided by probability of X. And so but if you see here, we're multiplying it, but we're getting rid of these two. So the fundamental naive Bayes assumption here is that each feature makes an independent and equal contribution to the outcome, which is why you can get rid of these. And so basically what this model does is it runs this formula on like every single tweet that we're testing. And then it kind of, this will be like a different graph where we'll get like two different probabilities. So for a certain tweet, like let's say it was make Canada great again. It's a little bit confusing because Canada might think that the tweet is like by Trudeau, but the make blank great again might make the tweet think that it's written by Trump. And so we'll get like a probability that it's, let's say like the green one is Trudeau and the red one is Trump. We'll get a probability on like the green curve between 0 and 1 if it was like written by Trudeau, and a probability on the red curve if it was written by Trump. And then the classifier just picks the probability that's higher. It's like, oh, there's a slightly higher chance that this tweet was written by Trump, so I'm going to pick that one. So that is what we're doing. And this part is like super simple to code. I'm going to explain it in a sec. Let me split screen. This is kind of annoying. Well, this is almost worse. Okay, that's okay. You can kind of see it. Okay, so we're doing 5 and 6 here. So 5 is training the naive Bayes model on word frequency, just like count. And 6 is training the naive Bayes model on TFIDF. So for both of them, we have some blanks here. The first blank is you create the multinomial NB model. And the code for it is super easy in Python. You literally just say like the name of your model, which we have here, equals, and you're just going to add this red part, multinomial NB parentheses. Who would have guessed? I love Python. And then the next line is training our model. That's also super easy. It's just the name of your model here. So it would be like this, dot fit. Wait, I can like type it out with you guys. Multinomial NB. Yeah, that's how you create a model. And then here, train your model. We're going to go count NB, and then it's literally just dot fit. And we have our training X and Y right here. So now that we've, oh, and then you do the same thing here. So we're going to create our multinomial model, and then we're going to train our model, but for this one, we're doing it on TFIDF. Dot fit. Okay, third step is now we're going to get our predictions on the testing set. So that is dot predict. Super easy. So you fill in the blank here with dot predict. And we're predicting on this testing set. Does that make sense? Does number 5 and 6 make sense to everyone? Oh, what's a document? Sorry, Shreya, I missed that 2 minutes ago. So a document is, like in this case, a document is a tweet. So each tweet is a different document, and a term is a word in that tweet. So TFIDF, term frequency inverse document frequency, just means like we're not just counting the number of terms, we're not just counting the words, we're also taking into account how frequent the word is in all of the tweets, in all of the documents. That makes sense. Okay. Is everyone good for part 5 and 6? Awesome. All right, I'm gonna take that as a yes. Oh, awesome. Thanks, Rachel. All right. Now we're moving on to part 7, where we're going to calculate the accuracy of term count versus TF-IDF. So to run this part, you're going to want to make sure that you've run all the previous parts before. So although you might have already run a few from the beginning, so you can see whether something's run or not by seeing like the check mark next to it. Yeah, so here I have a check mark here, a check mark here. That means it's already run. And then if I go here, you run the accuracy. And we should get a higher accuracy for TF-IDF than count because TF-IDF is better. Rachel is a goated moderator, true. Did everyone get a higher accuracy score for TF-IDF versus count? Okay, I see some yeses. Let's go. That's what's supposed to happen. Yay, okay, it works. Okay, this next part is kind of weird. I just thought it'd be cool to see like a graph of what's going on. So you can just hit play. And then you'll see this graph. It's supposed to be a graph of like all of the most frequently used words and then whether it was used more. You know what? There's a mistake here. Okay, let's ignore this part. I think I actually forgot to fix some bugs here. Sorry, my bad. Because it's supposed to be like, think great president Vietnam is like more frequent with Trump, but the do, lay, nu, for the French words are supposed to show up for Trudeau. So it's supposed to be like blue lines, but I'm gonna fix this, sorry, my bad. I'm gonna fix this bug and then send it over to you guys later. Okay, now is some part where we get to test our own tweets. So does anyone have any other ideas of like Trump tweets or Trudeau tweets to test out? You just like edit the text here for your Trump tweet and your Trudeau tweet, and then you just hit play. Let's check. Sorry,
Nikita,
what's up?
there seems to be an issue. It seems like someone said it might be about the import statement.
Which cell? The last cell?
You can unmute and voice your question if you like.
Not able to use that cell. Yeah, same here. Are we talking about the last cell?
Yeah,
No,
the
the
graph
one I had an issue with the cell that was supposed to do with the graph.
Oh, okay. You know what? I'm gonna fix the bug in that. I think that was my bad that it's not working. Also, there's some other data sets we're supposed to import and maybe there was some issues with copying. So I'm gonna fix that and then I'll send it in the Discord chat like later. Yeah, sorry about that. Is the last cell working for you guys?
Yeah, it works for me.
Okay. Awesome. What time is it? Oh, it's 6:32. Cell 8. Make Canada great again. Okay, let's try that. Wow, thinks that was Trump. Let's go. Canada is amazing. Trudeau. Okay, what if we say Canada is great? Because I feel like Trump uses great a lot. Oh, Canada is great. Thinks it's Donald Trump. Anyways, that's the workshop. Hope you guys enjoyed. Does anyone have any like content questions, confused on like TF-IDF or naive Bayes?
I have a question.
Yeah,
Oh, sorry.
go ahead.
I have a question. So thinks that Canada is great is Trump. That's obviously wrong. How would we like make it right? Like what steps would I need to do to like correct the model to make it more accurate there?
Oh, that's a good idea. So I think the reason why it thinks Canada is great is Trump is because it's putting more weight on the fact that Trump says great a lot versus the fact that Trudeau probably says Canada more than Trump. Like I think maybe Trump has said Canada as well, or Trump says great just like way more than Trudeau. So to take that into account, you would have to do some like sentiment analysis, but kind of split up a sentence into like phrases and then do sentiment analysis on each phrase. So it's a little bit complicated. So you split the sentence up into phrases, like if it's connected by commas or ands, you split it there. And then you have usually like a subject, a verb, and an object. So like Canada is great. And then we'd want to like associate the subject like Canada with like positive or negative. So I've actually never done that before fully, but just because English grammar is like really weird. Like a lot of times people don't talk with like subject, verb, object. We'll just be like,
I can talk about that a bit if you want, Nikita.
oh yeah, that would be awesome.
Yeah, so I actually do have some experience with that. So yeah, as Nikita was saying, it depends a lot on the way your grammar is written. So usually, so there are multiple ways to do it, but the state of the art way to do it right now is to just use a neural network. So if you guys want to read, there's this thing called BERT, BERT. So it's a model by Google that kind of allows you to, that's really good for sentiment analysis, and the interface is really approachable. So that, like, I had used it in the past, and it's pretty good. In general, the predictions are really spot on. So BERT by Google is one. I think there are like a billion variations on BERT. And I think there's a transformers library for Python. I'm gonna try to find it and post its link in the chat so that if you guys want to read into that, you can do that. And it's super nice. It's not as it's pretty straightforward too. So that's definitely something to look into if you guys are interested over there.
Nice. Yay, thank you.
I had one question. Do you know if it's possible to like copy over that utils folder or like get it somewhere? Because that seems to be the issue, because I don't have like that whole folder.
Sorry, I couldn't find the unmute button. Yeah, that's what the issue is with the graph. That's one of the issues. There's also a second issue where I have to fix a bug, but I can send that over. Should I send it like in the Discord? Basically supposed to be under content. Oh, maybe that's what okay. But I guess there's an issue sometimes when you copy it. So I will send that over. Okay, so I'll kind of show you guys what that is. Basically, since this code is adapted from someone else, the graph part, he kind of like abstracted certain functions in creating the graph. So if you do like a bash command, pwd, to see like where we are, we're in /content. So you go to /content, and then I can give you guys the code for these two helper functions. You have to make a folder called utils, and then these two helper functions, and then the graph thing should work. Maybe I can just like copy.
Nikita, could you explain naive bears? Like a couple of people are confused about that. Could you maybe talk about the theory behind it a bit?
Yeah, sure.
Yeah. Well, once you're done with this, like.
I think this one is actually not as important because it doesn't work as well. So once I figure out what the bug is, I can send it to you guys like later, like tomorrow. Let me for a second in the naive base slide. Where did the slides go? Oh, here it is. Okay. Chat. Word order does not matter when making text tweets because basically it just counts the frequency of each word. and then takes into account like the frequency of the word in all of the tweets. So yeah, word order does not matter, but that would be a way to improve it. Okay, so naive phase. Maybe let's go a little bit more into this. So give me a sec, let me find a cool picture.
I have a question about the weight.
Yeah, what's up?
Yeah, I was wondering, how does the weight factor into all of this, and how would manipulating it affect the entire situation, the entire code that we have?
Yeah, good question. So the weight here for each of these, we give let me think for a second. Okay, so basically for each like tweet, we come up with these different we come up with a vector. And so, okay, so the vector, there's going to be a different vector, which is like a row of a matrix. So we have like a matrix where each of the columns are the different words and each of the rows are the different tweets. And so for each tweet, we have a vector in the matrix that has, for example, 1.31 and then 1.31. So that's our matrix here. We have our different vectors. And then these vectors get plugged and chugged into this formula. So it's taken into account with this probability. It's a little bit more complicated behind the scenes, so I've abstracted it a little bit, where it makes like a Venn diagram to calculate like with this matrix, like, and the different vectors, like probability of being Trump or Trudeau. Sorry, I've abstracted a little bit here, so I didn't go that much into detail. I wasn't sure how long it would take.
Yes.
Let me find a naive phase thing.
So would giving a different weight to, let's say, an adjective or a verb help us in getting a more accurate model?
Oh yeah, that's a good question. It would definitely change it. Like, are you thinking of giving more weight to nouns or something like that?
Yeah.
Yeah, that would change it. I think there's like libraries out there, Python libraries for like nouns, for verbs. And so what you do is you'd import a library of nouns, you'd import a library of verbs, and then you could like label each one or create two different matrices, like one for nouns, one for verbs, something like that. And then like multiply the nouns by a higher number than the verbs. And so then when it gets plugged into this formula, the nouns are like weighted more. That's a good idea.
Yeah.
What's the lowest weight that a word could have?
I think it depends on like how big, like how many words you have total. So like if you have 2 words, like I guess the average of them will be like 1/2. But if you have like 100, the average of them will be like 0.01-ish, you know? So it depends on like, you know, or if you have like certain words that are repeated a lot of times, you know, and certain words that are just there like once in one tweet, that could have like a way less weight. But yeah, I mean, it's like endlessly infinite, right? If you have like a ton of different documents. In a good way.
There's also a feedback form in the chat. So if you want to fill that out whenever you're about to leave the Zoom meeting, that'd be great.
Oh, someone posted a question. Is it possible to introduce correlation, as in Canada with great will result in a higher probability of being from Trudeau? I don't know. Pankaj, do you know the answer to that one?
Come again. I'm sorry, I did not pay attention. I was
No,
trying
you're
to
fine.
link the book.
If you check in the chat, Saad posted a good question. He said, is it possible to introduce correlation, as in like correlating America with gray?
Oh,
like,
I see. I see. Okay. So you could, in theory, do that, but the aim of these ML models is to try to not do that, because at the end you could always just make a model that looks for these words or looks for these patterns and tries to figure it out. What we're trying to do is automate as much of it as we can. So that does depend. So I'm not entirely sure how you would go about doing this in like naive Bayes model, but I know with NLP you can add a lot of context to what's being read over here. So that's, I mean, definitely something that can be done. But I'm sorry, I have a lot more experience with like the neural network side of things, because that's what I've been doing for like my data mine project. So I really can't speak for using like a regular model, but yeah, I'd be happy to chat about like neural networks and that kind of stuff if you guys want to later.
That's super cool. I wanted to go into neural networks, so then I was like, there's no way it's gonna train in time.
Yeah, no, it's definitely gonna be it would be a long shot to try to do it in like a short time, but yeah.
Yeah. Okay, let me see if I can explain naive Bayes a little bit better. Please. Yeah. Go. Okay. So let's say like A here, like probability. So we have two different probabilities here, right? Like probability A and probability of B. And then we have some conditional probabilities, which is like probability of something given something else. So our A here is that Trump wrote the tweet. And our B here is that our tweet contains the word great. So this formula is basically saying that the probability that Trump wrote a tweet, given or like assuming that the tweet contains the word great, equals the probability that the tweet contains the word great, given that Trump wrote the tweet, times the probability that Trump wrote the tweet divided by the probability that the tweet contains the word great. That was like a lot of words, but basically there's like these different probabilities in a Venn diagram. Let me make like a Venn diagram here. Or where's like A and B, and then we have some overlap. So it's like taking different parts of these Venn diagrams, and that's like just a rule in statistics, taking the probability of one given another. And you'll understand this kind of like relates to our TFIDF stuff that we were doing, where we were like calculating the probability that a word is in all the documents, or like anyways, I don't know if that makes a little bit more sense on what this formula means. But they make an assumption when they use this classifier that every single tweet affects your prediction equally. And so you get rid of the P of A and the P of B, and you make this assumption that P of A given B equals P of B given A. But it becomes a lot longer, where we're not just trying to predict like, you know, probability that, so you know how I said we have like two different curves? Let me go back to here. We have two different curves here. So we said the blue one is probability that a tweet written by Trudeau, and the red one that a tweet is written by Trump. And so that probability is right here, probability of A given B. So we have probability that Trump wrote a tweet given that the word contains great. And so we'd calculate this probability, and then we also calculate another one, like probability that Trudeau wrote a tweet given it contains the word great. But obviously our tweets don't just tweet out the word great. They're tweeting out tweets that have a lot more words than that. So that's where this thing on the bottom comes from, where, let me type this out, that'll make a little bit more sense. Okay. So I kind of want you guys to see what I'm typing. Okay, I'm just going to type it like right here. Okay. So we're going to say probability A given B and C. If we want to do like probability that a tweet was written by Trump, given there's the word America and great. Or probability that a tweet was written by Trump, given that there's the word America, great, like make, and the word again. And so that's when this formula becomes longer and longer, where we have like equals probability of B given A and C given B times the probability D given C times the probability E given D. You know, you're like multiplying all those different probabilities. And so once you take that like vector and you calculate those probabilities and you multiply them, that's how you get to, I don't know, does that make a little bit more sense for how naive Bayes works?
Yeah, I think that helps.
Okay, cool.
And then I put this question in the chat also, but how does the program get from like these numbers that are calculated to the actual prediction? And then especially when it's in that like little pink zone there where it's like overlapping.
Yeah, so basically we're gonna get two different probabilities. So we're gonna get like a probability here for probability that it's Trump, given there's the word make America great again, and then probability that we have that it's gonna be Trudeau, given we have make America great again. And it's gonna have different A and B values and stuff like that. So we get two different numbers. And so basically you're just gonna get like probability that a tweet was written by Trump equals like 0.9. Probability that a tweet was written by Trudeau equals 0.8. And so in the pink zone, it just looks at like, it's going to be close, but it looks at which one is higher. So obviously like the blue zone is like very clearly Trudeau. The red zone is like very clearly Trump, you know, if like that probability is just like so much higher. The pink zone, the numbers are going to be pretty close, but it still takes whatever is higher and it spits that out as its prediction.
Gotcha.
Cool.
Are there any other questions?
Isn't this conditional probability? Yep, this is conditional probability. How does this program get from the numbers that are calculated to the prediction? Especially when they are keywords for both authors.
Yeah, that's what I was talking about a
Gotcha.
second ago.
Okay. Did my explanation kind of make sense?
Yeah.
So basically
yeah,
it's not like
sense.
a binary like keyword for one author or another. There'll be like a probability for each one, for each author.
Sure.
All right, I think we are done. Thanks for coming, guys. This is fun. Hope to see you next time, and feel free to like chat on Discord about this. I think some people were asking about the graph part. So once I fix that up, I can send the fixed code and we can talk about that. Oh, no class tomorrow. I didn't know that. I didn't see that. Would we be able to make it give us the model's certainty? Do you mean like the, like how accurate it was? Yes, okay. Yeah, so we did that actually in step number 7. If you click the play button next to step number 7, as long as you've clicked all the previous play buttons from 1 through 6, completed that, you click the play button for number 7, and it calculates the accuracy score of TFIDF with naive Bayes versus count with naive Bayes. And as you can see, the TFIDF one has a slightly higher accuracy score. Oh, that's not actually that much higher. Wow. How uncertain is it? Oh, I get what you're saying. Yeah, there is a way to do that. I can DM you that later. Or I mean, I can just show you. Let's see. How would we pull that out of this? Yeah, I'll figure. Basically, some of these libraries, they do like a lot of the work for us. So to get a small part, probably be pretty easily Googleable. Does this program have an accuracy score? What do you mean, Torrin? Like, is this not an accuracy?
I guess like if the probabilities are really close in some cases, is there like any part of the program that tells you like we're this % sure that it's one or the other?
Yeah, that's a good idea. I think I should break down the abstraction that Python does here and then like figure out a way to just print out those two probabilities that we can see it. Let me write that down. Just see if there's any last minute questions. Yep, I think we're good to go. All right, thank you everyone. I'll be sending a few messages on the Discord with some of those follow-up questions. I'm gonna stop sharing and end the meeting. Bye guys. Make sure you fill out the attendance form that was sent in the chat.